Right, so you know what really gets into my nerves? My nerves. So there's one nerve in particular that I really don't like. So it's called recurrent laryngeal nerve, if I recall correctly. It's this boy. So what what am I showing you? So you have larynx in here, so that's krtań in Polish, and you have some nerves which connect, larynx to your brain, as you would imagine. And one of those nerves is called this left recurrent laryngeal nerve. And instead of going, this nice clean path to here, it goes underneath your aortic arc and then back to brain. So it's like, whoop. And well, I'm sure this is not the very first instance of badly designed thing you saw in your life. So let's maybe talk about other animals, how it looks like there. So I think we've got it not that bad, actually, because, it's about, I would guess, 20 centimeters or so here. But the giraffes, oh boy. So those two white bubbles you see there, one of those is brain and the other one is, larynx. And, following the nerve template we've seen before, you would maybe expect the nerve to, span, I don't know, like in here, like through here maybe, and, fuck no, it goes all the way here. And this is as much legacy code as you will see in nature as it goes. And oh. Some kind of a bore. Yeah, I recall something. Which were curling and drilling into its head. Inwards, yeah. No, it could be worse. I guess it could be worse. Yeah, the giraffe gets to live, so obviously the better choice. So the natural question to ask here is like, wait, why? So, what's going on here? And the question is simple. The answer is actually also pretty simple because, it all started million life years ago with fishes. And, in fish, it's more straightforward because you just have, they have the hearts closer to the brain. So this connection that goes through this aortic thingy makes more sense in their case. Then we have us, more or less like that. And then we have giraffes, so pretty wild. And with this introduction, I would like to welcome you to my talk, which is also called Wait Why, so part 2. A little bit about me. So I'm Patryk Wychowaniec. I work here at Anixa, have been for 4 years. You will find me online at my blog, where I do some Rust post series, if you're like into machine learning, genetic algorithms and stuff, so you can check it out. I try to, explain concepts from the bottom up, so no knowledge required. You will also find me on GitHub and Twitter. And with that, we can go to the actual presentation. So I'm going to show you 5 things that I've stumbled upon while writing Rust code. Those are, things that maybe not bother me in the language, but they took some time to discover, on the code reviews, or time to discover, why it works a certain way, why it's most likely here to stay, and some rules of engagement. So I'll be doing live coding. After each of these points, we'll do a little bit of Q&A for the code that will be on the screen. So if you will have some questions to each point, I'll just, say that this is the Q&A time. And yeah, so we're starting with self-audit. And one thing. Yes, I can. And I'm also going to switch to white theme. So if somebody's on YouTube, please beware. Boom. I do not hear any screams, so went well. Right, so we're starting with self-auditing. So I'm writing some, first I'll write some code and then I'll ask you if you see it all right so that we have some comparison point. I might have. This one? Okay, is the font size all right? Okay, right, so we have some wrapper. Let's do some constructing work. Who can see what's wrong with this code? Nothing, it's great as it is. We'll go later and implement some print display function. So it will take one of those wrapper thingies to where we can actually display it. Sorry, I have to start Rust Analyzer to get some code hints. Okay. This one. Right. So pretty standard. We have item.item because we need to get access to the actual underlying item. And as it is right now, this code will pretty much work. Right? Simple as it is. Let's say that we want to print it twice because, you know, printing doesn't actually need to eat the item. So first of all, this code as it is will fail because obviously we are, this wrapper isn't clonable, so it gets moved into here. And one of the solutions would be to, you know, make it copy, but I don't know, let's do strings. Those cannot be copied. So naturally, if you pass a value somewhere and you don't need it to be eaten, you do a reference. So the simple solution would be something like that. But actually, it's a bit unidiomatic because it's the same case as in with option of t. So it's actually better to go with option of the reference inside. And the reason is simple, because if you have already a function that takes such an item, you can always transform it to option by just wrapping it with none, sorry, with some. So this would be something like that. This gives you option from t, while doing it the other way around. So getting ampersand option of t in this case is not possible with safe code. So like instead of this one, this is like the more useful type. But
so it's better optimized.
Might be, yeah. Yeah, it's possible that if you have option from references, it's the same size as t, yeah. Yep.
So it's the pointer size, so it's word.
Pointer size there. But you know, in this case, the ampersand operator doesn't work because those are two different types, and we need a way of, you know, converting from wrapper to wrapper of ampersand t. Usually, this method is called asref. You will find it, for instance, on option, on result, I think also. And it's pretty simple to implement. So we do asref. It returns wrapper of ampersand t. And the item is borrowed. And this is the place where the code breaks, as it is right now. And the error message is kind of, I think, semi-helpful, because it says, maybe I'll show it like that so that it doesn't wrap. It says mismatch types. It says that it expected wrapper of ampersand t, and we return it wrapper of t. And if we take a look at the code, this can be a bit baffling because we do build a new wrapper that we pass, you know, ampersand into. And does somebody want to guess what's going on here? Okay, let me show the whole code. Yeah.
Type help is the type of your entire input block.
Yep.
Which is help.
Yeah. So this is, you know, pretty simple mistake. It can be difficult to spot because it doesn't actually mention, you know, the fix in display in the error message. But the thing is that the self always refers to what's inside at the beginning of the input block. So it's as if the code here did something like that, which obviously doesn't make sense. It should be ampersand or just, you know, elided whatsoever. So simple, but it can take a few minutes. All right. Now something a bit more difficult. Let's say that we have database connector. If you know databases, you know that they have concept of transaction. So if you run a query in a database, transaction allows you to confirm that you want to save the changes or cancel them. And in our design, let's say that it takes database as an owned value. Customarily, the method that actually saves the changes is called commit, because it ends the transaction. We can just take self. And let's say that the actual implementation is in a separate function that takes database. Because I don't know, we can have database commit as well, and this way you can reuse the stuff. There is some reason for that. As it is right now, the code will work. So if we do transaction db database commit, it will compile, though obviously it doesn't actually do anything. But there is a way to make this code break by not changing anything inside this block. And I think this is one of the few cases where actually adding a trait implementation breaks your semper guarantee. So if this was already released as version 1, if now you do impl drop, this can be actually a breaking change, and you would need to release version 2. And the reason is simple, although the error message in this case is also not so clean. It says that we cannot move out of transaction because database does not implement copy. And in this actual example, we could just derive copy, but if we imagine that there is some actually, I don't know, some socket in here, some actual code where we cannot do copy, then this breaks. And the problem with this is that the destructor is always called after the item gets out of scope. So it's as if the compiler added here self-drop, and the compiler doesn't care about that we don't access the database in here. From what it knows, we could do something like, even just print it. And if we did, this code will be invalid, because if we move the database from ourselves into commit, and then the database gets dropped in here, we just don't have it in here anymore.
Why doesn't the structure run at the moment we move the first field out of the struct? Actually, when you reference the DB member, at this point our structure should get sort of structurally decomposed.
My rough guess is that you can have what's called partial borrow, partial move. So for the sake of argument, let's just have two databases. And this is obviously valid because each of the, if not for the drop block, on its own, this is valid. We can move the first and then the other one. But for instance, if we had a field in here that was, I don't know, int, where is the place that we should call drop? Is it in here? So like in here? Or in here? Because only this is the place where you don't have, the rest of the types are, not copyable.
Right. The idea is that when you drop something, the idea of dropping the source of this is to release the resources. So basically to drop everything, the structure out. So if the job will be called anywhere before it was passed to some function, then every field of the structure will be dead. So you cannot drop it at all, right?
Would matching here help?
Yeah, so this structuring, no, because this structuring is the same case. So it works when you don't have the structure. Well, in this case, this should be just DB, obviously. But as soon as we add a destructor, the type is not destructible.
Right.
Yeah, I forgot the word. Destructible anymore. Well, for the same reason. So this would be the same. It suggests to add ref, which partially solves the issue because then you have ampersand database in here, but it doesn't help you in actually invoking do commit because you need owned DB for that. And actually, usually when you have like database connector in Rust, this is not an abstraction. This is actually a pretty useful thing to have. And for a reason I'll show right now. So first of all, how do we solve this issue? Because assuming we have access to the database in the structure, or we might have, one of the solutions here is to make it optional. And then when you create the transaction, you always assign it to some, so that it starts, as visible. And then when you need to have the owned version of your inner type, you use function called take. It's a function option. When option is some, takes return you the inner value. When the option is none, it returns you, well, none. So we'll take unwrap, and this solves the issue. I only make it mutable. And this also solves the issue with the destructor, because then inside the destructor, you just don't have the DB anymore. So if we do something like that, it will say false. And the way it's usually used is that if we imagine that we actually have some code that is able to run transactions, queries, so like something like that maybe. Okay, then let's say we have something similar on the transaction. And then first of all, we cannot just do self DB query because it's option. So in this case, first we call asref to get option of database, then unwrap, then we have the query. And the way this pattern is used then is that inside the drop, we can check if the database is present. If so, then we can force the transaction to get rolled back. So in here, if we imagine that the do commit, just queries to the database, I don't know, save changes. Then inside here, we can query database with undo changes. And in the other hand, commit must have been already called because otherwise we would have the database. And this is useful because then if we have a transaction, we can do query something. And in this case, we will see something and then save changes. But if we forget about commit, we will automatically get something and undo changes because the destructor is always called, unless panic in a destructor, but let's say it's always called. And if we have the database in this case, because commit was not called in this flow, then we can do something extra. Otherwise, we've lost the database. So this is pattern you will see frequently in various database connectors. I know Redis clients, possibly not because they don't have transactions, but like with relational databases, it's pretty common. And then one thing, so this unwrapping might see funky, like, where does it actually panic in this case? Because clearly in the happy scenario, it all just works. So why do we need option in the first place? And the issue is that you could technically call query from in here. And then if you call commit, then this code will panic. So like that. Because you try to query, but you don't have the database anymore because you've already dropped it while doing commit. So this unwrap is actually something like query called inside drop. So this is the edge case it, this is the edge case it got us from. All right, so any questions for this part? Yeah. I think you claim that there's the only situation when adding can pay attention on the tray. One of those, one of few. Oh, yeah. Because I know that you have also like send, sync, auto traits you can implement.
Kind of implementation of edit trait.
No, actually, the way it's designed is that specifically with regards to orphan rules is that usually, if not for drop and auto trait, you can always add a new trait, a new implementation of your trait to your type, and it's not a breaking change.
But I'm wondering what the situation when user auto type it's sourcing, like using your two traits. One your trait you are not implementing, and another trait you was implementing before on your type with the same single function. And now this function is no longer callable directly, and you need to use the unified function.
In this case, yeah, I think it's a gray area. So it's the same case as if with star imports. So in principle, adding a new type is not a breaking change either. But if you have star import, then it could be, because you could have create A, source everything from there. And if we say that there's a type foo, currently only in crate A, so then if crate B also has a type called foo, then it's kind of sort of breaking change because you have ambiguity now.
Yeah, that situation, and here you don't need to just need to demonstrate it before completely times. No, because you could use the trait for chemicals.
You could
and it will just implement the side. I know it's a case, and I know it's a situation. I'm just careful about.
Yeah, I think the rules regarding, the precise rules regarding breaking semantic versioning are still like being developed. So.
Remember, I faced this issue. That's my thing.
All right. Anything more before I, drop this code and drop this code? Yeah.
I just have a question, slightly related. Is bumping minimum supported draft version a breaking change or not?
That versions were dropped recently by advisory. It's not advice anymore.
Oh, wasn't that way?
Whoa. I mean, it's not. There was some change, maybe not drop, but there was some discussion about it.
That's nice.
Because of issues created. But I don't have some time.
All right. Well, then we have no derive, no cry. So this also comes up quite often when you work with generic types. So let's say that we are not very innovative, so we just want to write a list. Well, probably should have called just vec2 because this won't be linked list, just wrapper for vec. So items vec_t. Let's add some function such as push. And let's add a derive default so that we can actually, create instances of this list. So list default. Like that, and obviously also debug in this case. And as it is, this code will work. It's slightly broken in a way that's difficult to see on the first side. I mean, broken depending on how you define it. I would define it as broken. And the issue comes up when inside this list, instead of using something like &str, we'll use something that doesn't have default constructor. So let's say we have some myString. Like that. And now the code will say, the compiler will say that myString doesn't implement debug. How true, but not this one. And that myString default is not, it's not how it would precisely, just implemented, right? Because the message is a bit cut, but the trait bound myString default is not implemented. And intuitively, this doesn't make sense because if we replace this with vector, then this code works, and rightfully so, because we don't actually need empty string. Well, we don't have empty string anywhere in here, so why would it be required to use it with our list? And this is a problem known as implied bounds and perfect derive. There's a great article from Nico Matsakis on this subject. If you Google these 5 words, you will find it. But to briefly say it, most derive macros, when you use them, add the same bound to the t type you have in there, whatever types you have in there. So what this code expands to, if we did it by hand, is impl t default for list t, where t is also default, and then it's like that. And this bound is overzealous because we don't actually need for t to be default to implement this type, because this is as easy as this. And this will actually solve our problem. And the reason why the compiler does it this way is for also kinda related to semver, kinda because of compiler troubles in the past with self-referential types, because in principle the bound we need here is vect implements default, and then vector implements default for all of the types, so this would be also an all right thing to do. And why the compiler does the overzealous version of just assigning t is that in the past the compiler had troubles with referential types. So if we say we have something like that of parent list, in our perfect version, this would have to generate bounds such as this is default and option from self is also default, which takes a while to settle on, but let's say. And because this self here is self-referential bound, the compiler in the past, a few years ago, had troubles with proving that this impulse default, because, well, POV, you are compiler, you are trying to check if this is valid implementation, so easy one. And then you have to check if option of self is default. Oh, great, so for that I have to check if this holds. Oh, okay, this holds. Oh, okay, we're back to square one. Now the compiler understands this. If I just added box here, and then this technically should be box self, and this will work. But the old logic stayed for one important reason also, which is that usually when you add a new private item into your type, this is not a breaking change. So we could add something like, I don't know, item t, whatever, and with this automatic generated bound, which is too much, but it would actually wouldn't be a breaking change, because this bound was here before and it is right now when we added it. But with the initial mechanism, so with the proposed perfect derive, this would be the first impl, then we add this bound, this creates a second impl, even though the only thing we've done was modify some private field somewhere deep in your type graph. And this is already a problem with auto traits such as send or sync, because this is exactly what they do. You can add some random type somewhere, and suddenly, even though you don't spot it on the first sight, your type is not send or sync anymore. And this is frequent source of frustration for when you bump a version of your crate. Well, not your crate, somebody's crate in your program, and then your asynchronous code stops working because someone somewhere added some magic type that propagated up into your struct somewhere. And this is why the current logic of using just the generic bounds you passed instead of the actual types is pretty much here to stay. Those cases can be a bit difficult to spot because, well, in this case I've showed you, for instance, with list and vector. So what you should do instead of doing derive debug is just implement the default by hand. But some cases are a bit more tricky. For instance, if we had another kind of wrapper, and if we do derive clone, then we're back to square one because we don't actually need for the t to be clonable to clone arc of t. So this would actually also need to be changed from derive to manual implementation that calls arc clone. Or I think there's a crate called derivative that you can use to automatically generate it. I think probably something like that, if you don't really writing by hand. But it's important to at least be aware that, you know, sometimes doing the derive way is not actually the best way, even though the kinda, you know, the generated code kinda looks like boilerplate that the compiler could have done in the first place. Right? Any questions for this part?
You meant the generated code or the generate code?
Oh snap, I lost context on that sentence, so I'm not sure what I meant. Could you say a bit more?
No, just my brain.
Right. So also I'm curious about one thing in this case before we go further, which is if Clippy catches this case. Okay, let's comment this out. Oh no, so it doesn't catch this. So you have to just like be aware, or maybe write a lint for that. If you have some time, this would be useful. And the actually related part is trait called derive. So you might probably use derive even if you don't actually know that it was called there. And to understand it, let's focus on this part. Let's say string from hello. So somewhat predictably, this works. And when you box this, this also works, but this begs a question, why does it work? Since there is a function on string for length, but there is no function on box for getting the length. So if you do something like that, and this actually fails because you cannot have, well, yeah, this doesn't make sense. So what is the magic here that allows you to call length kind of like through the box, or, you know, other types such as arc or I know RC, or actually in this case string itself. Yeah. And this trait is called derive. We can go back to the list thingy, and there's a trait called, as I said, derive. And derive is a trait which compiler invokes on a few occasions, mostly when you do the dot operator. And what the derive operator does is that it allows you to specify that your type is kind of like a wrapper for something. So in this case, we might imagine that the list is just a wrapper for a vector, and we can just return it. And what the code will do now, if we go back to some useful field list, is that now on our, you know, items stuff, instead of having just the pass function as we would have otherwise, we can call everything that the vector also has. So we can, for instance, call len, and this will work if I just make it mutable in here. That's two. And this is mostly useful for, you know, things like boxes. Although I do also have a few uses for, you know, types that wrap something and then provide, you know, extra functions, kind of like trait extension style. And there's also like cousin to this function, because the ref also only grants you, you know, read access. So you couldn't have done something like, probably easiest to do is, you know, remove the pass function in this case, because vector also provides a pass function, but we cannot call it yet because we do not have not implemented the ref mode. And it just, you know, refers to the item. And if you, for instance, use Baby, which is the, you know, Rust crate for making games, then you might know that Baby also uses this pattern to track changes when something has changed, because if you have just the ref, then we know that the item, the value we return couldn't have been changed. But if we use the ref mode, we can toggle something like, I don't know, dirty to true. And then we can know that some collection was probably modified if the ref mode was called. And the reason why I'm mentioning this trait is that actually I had a case in my job when I had something like that, I think. It was, I think, also a wrapper for some type. And usually the target type in here doesn't have to be so specific. It doesn't have to be sized even, because we always return it through a reference. Then it could be a nice idea to return like more useful type in here. So if in the future, instead we imagine that instead of using vector, our implementation switches to, I don't know, some box of slice, whatever, and in some magic way we implement push, then if we derived to vector, then this wouldn't work because it's obviously not a vector. But with slice it would, so it's a good idea to keep the type in here, more abstract. And I refactored code that was using it, and I broke it because there was one place in code that was calling, I think, capacity. And I think it then either stopped working downstream. So I had, my crate, I committed the changes, and then, some crate downstream broke. And so this is like more kind of beware. So if you're writing from scratch, then it's a good idea. But if you refactor in, then probably, switching types to the more general ones doesn't always help. Right, any questions for the ref part? Nice. This brings us to the last case. Smells like lifetime extension. This is quick of the language, I would say. So I will go back to text mode so that it doesn't actually underline what the issue is. And I'll write 2 lines of code where one of them will be legal and the other one will be not. And they both look like they shouldn't be legal. So string, yeah. Right, they do kind of different thing, but let's maybe call one of them so that makes kind of sense. And you can do a quick question round. So who says that this code will not compile whatsoever? Both are broken. Okay. Who says that the first one, just the first one is broken?
First one is broken.
Just the first one is broken. Okay, and who thinks just the second one is broken? Okay. Yep, so just the second one is broken. And the reason is kind of, should be this one, yeah. And the reason is that there is a mechanism in Rust called lifetime extension. It kicks in cases where we have ampersand of expression of, something. And what the compiler does in this case is something akin to string new, and then including where the value gets dropped. So this is just like a shortcut for doing this. And the other one, in this case, the compiler allocates string new, and then you try to reference something when it's dropped. So this is more like, format it. So this is more as if you've written something like that, which is obviously wrong because you allocate the string dice in here, so we cannot return something from the string in here. But ampersand something is like, edge case. It's simply defined to be working this way. And it comes useful at few occasions. You might have even used it without being aware, because one of the cases where this will get kicked in is something like this. So this uses this mechanism of lifetime extension twice. Contains access function. So first of all, this contains is not defined on a vector, it's defined on a slice. So what the compiler needs to do is something like that, numbers. So let's make that impl1. Then has to, maybe if I annotate the types in here, then has to call the derive operator to do something like that, about impl1, which transforms it to slice. Then we have the third temporary, which is just the free. And then what actually the code in here does is just tmp2 contains tmp3 or, ampersand. And so if you were wondering, like, what's the random use case for ampersanding stuff? So the ampersand is just like a side effect. The major use case for that is so that you can call stuff without actually having to worry where this data gets released in a few useful cases, such as this one. Because this would be this is way more verbose that just, numbers contains whatever you want.
I think it's quite common in the Rust book, in some test implementation. I remember seeing it coming from C and C++ and being super what are you doing? Where's this legal?
Yeah, there are some cases. Although obviously if you're trying to, in one place, do something like numbers, I don't know, get to unwrap, then this will work in this case. But if you try to assign it, and this will not, because and now I'm baffled. Maybe I have to use X and do something like that to bring the scope, where I want it. Yeah, right, and I have to actually return this value. So something like that. Oh, no, now it's temporary that gets dropped. Right, yeah. Which begs the question, if now I wrap it like here. Okay, yeah, no. Right, so any questions for that, or any of the previous ones, since this is the last case I have?
The general public consider this or something, or a neat convenience.
I think it's a neat convenience. To be fair, I had it written down for like a few months now, but I don't recall where it popped up in code. I read it because there's a dedicated chapter either in Rustonomicon, so like the secrets of Rust book, or I think even in the main book. And there's a dedicated chapter on lifetime extension and where it triggers. Also regarding the scoping, so where if you do this ampersand thingy, what is the actual scope of the variable you're creating this way? I think it can be surprising. So for a brief moment, I thought that this could work, for instance. Now I know that it won't. But overall, I think it seems helpful.
I think it depends only on the server first. But that's why it doesn't work, and that's why it's basically reasonable. It doesn't ruin anything because it's like only on the level where we don't need the ownership anymore. You can say, okay, it's now there's no ownership.
All right. In this case, thank you so much for listening. I'll try to have some more fun cases for now, because I think this was the second part, so I've shown all 10 cases from Rust I had. But hopefully, some code reviews and PRs will bring some more stuff. Thank you.